ready to go on to our next talk. So Victoria Broje has 20 years of experience in environmental science, emergency planning and response, R&D projects, and outreach. Since 2006, she has been supporting Shell businesses worldwide as a subject matter expert for spill response technologies and environmental impact assessments. She works on many committees developing best practices in emergency response and environmental protection, and chairs the API Science and Technology Working Group for Oil Spill Prevention and Response. She's also chair of the board for Clean Caribbean and Americas, a nonprofit organization dedicated to outreach on spill response and environmental protection topics. We heartily welcome back Victoria Broje to this workshop. She's spoken at previous workshops on other technologies. Today, she's going to be speaking to a rapid field test to evaluate slick dispersibility.
Thank you. I'm very excited to be here, and I'd like to also introduce Gina Coelia, who you know really well, and Anne Slaughter, who are also here. They are principal investigators on these research projects, as well as Michel Bufadel. He was going to call. I'm not sure if he's on the call right now. So this is a very exciting opportunity to present, because this is the first time we are unveiling this project to oil spill response communities. So very excited to share our results. If I can change slides, that's an obligatory eyesight test. It says that if you were waiting just for my presentation to buy Shell stock, you probably should not be doing that. So speaking of dispersants, as it's already was discussed, oil properties are rapidly changing due to weathering after the spill. And because dispersants have such a limited window of opportunity while they can be used on relatively fresh oils, it's very important to assess, is that slick under those conditions can be dispersed, or it's probably not a good technique for that. And this is one of the questions that is asked when we are applying to regulators for dispersants approval. And it potentially, it's kind of a question that may be litigated in the future: who made the decision to use dispersants and based on what information? So we have several ways to evaluate big dispersibility. We can do it through modeling. We can use initial properties like density and viscosity and environmental condition and try to predict it, how viscosity or dispersibility changing over time. Of course, it's maybe a challenge, especially when we don't know initial oil properties. And of course, modeling of emulsification is very complicated, so we cannot always rely on those results. We can also do a test spray from the plane or a boat, but sometimes it may require separate approvals from regulators. It may take time, it may be expensive, and both may be occupied with spill response activities like mechanical recovery. There are also ways to evaluate it by using small tests of oil slick on the response boat. And over time, several test kits have been developed in Norway, in US, in Australia, and most recent one in UK that you can see here on the screen. I am very glad Alexandria presented you Buffalo flask test that was also marked as potential field test, but you may have noticed in her presentation how sophisticated it is, and it's definitely not something that responders would be able or willing to do in the heat of the response without any science training on the response vessel. And all the other tests, they're relying on handshaking, and it's can be a somewhat imprecise science, because as we all heard, mixing is a very important parameter in dispersant's effectiveness, and how hard you shake, how hard you mix really drive the results outcome. And when we approached our response co-ops in US, and when we asked, would you be willing to use some of these field tests to do this test in the field and give unified command and environmental unit indication whether this oil is dispersible or not, they mentioned that there may be a few challenges. One is to use this highly scientific equipment that they are not trained to use, calibration, things like that, fragile equipment that is not really suitable, and it's really not their job. And also, they really ask that responders' responsibility need to be removed from this test as much as possible. In other words, that if anybody wanted to ever sue anybody for or responsible party for decision making on dispersants, that cannot be tied back to that individual who did the test and shook it and interpreted it. So the goal of this project was to develop a rapid dispersant field test kit by incorporation of automatic mixing system that would take away that responders' inconsistency, responsibility, variability between tests and between people, and make it very consistent that every time we can rely on the results and we can compare between days, between oils, between dispersants, and receive a more reliable information, and also protect our responders from any kind of litigation. So the charge that Gina and Anne received was that we need a simple kit that OSRE personnel can use without any training or with absolute minimum training. It has to be easily stored, very robust. It should be on the vessel for 5 years and be pulled up and still working without any calibration. It should be quick, it should be qualitative. In other words, we are not going to ask responders to make precise estimations of percent of effectiveness. It's really for them just to do the test and send images or videos to the command post where a scientific support coordinator or other scientists can interpret it. And that was kind of the framework that we started working with. And we want to highlight from the very beginning that this is really just one more additional piece of information that response community can get from the field to help their decision making. It does not replace any existing processes, decision trees, prioritizations, any other test that people want to use. It's really just to help if you have this kit, if responders are available and willing to do that. And this is just one more piece of information on a unified command that a scientific support coordinator or environmental unit leader can look together, discuss, and offer as additional justification for dispersant application or show why it may not be effective. And of course, absence of this kit or results of this kit should not delay response operations. I'm a big believer in advisory committees and working as a team. So because we all come from different angles and have exceptional expertise. So when we put our heads together, we always get to better results. So for this project, we invited representatives from 5 agencies, from Coast Guard, NOAA, EPA, BSEE, and TGLO. We had 5 oil companies. And we had invited MSRC and CJ because ultimately they're the end users of this toolkit, and it really needs to be suitable for them, and they need to be comfortable using that. So the first thing that Gina and Anne did, they evaluated commercial off-the-shelf available mixers and shakers used in dentistry and in cosmetics and the food industry, and played with them and evaluated their pros and cons. And in the final report, we have a very detailed analysis of what they are. And of course, because it's all about mixing, selection of this mixing device is critical to this project. Because if you think about this food grade blender or your mixer, if you throw some oil with dispersants and water into it, it will disperse even undispersible oil. So these results will not be representative, not of the type of ocean turbulence, not of the processes that are happening, not droplet size distribution. So really things like that can be done, but it's really not what we are looking for. We were looking to simulate something a bit more natural and more akin to ocean mixing. So as a result of this analysis, this orbital mixer that you see on the picture was selected for a variety of reasons. And in addition to mixing, they also looked at a variety of bottles that can be used. You're familiar with the swirling flask, baffled flask. There are also square-shaped bottles. There's a variety of bottles that could be considered. So Gina and Anne played with them, characterized them, looked at what kind of turbulence they create, and eventually settled on this dimpled Ermeller flask. We didn't want to have a baffled flask on this test, not to confuse with baffled flask used in EPA and more comprehensive analysis. And also these flasks are a bit easier to come by and a bit less fragile. So they're a dimpled flask, they're not baffled flask, just want to highlight it. And on the next picture, I'll show you the size of those dimples that also facilitate turbulence. And next slide, I'll show you how the speed was selected. Also, they evaluated mixing time, how long it should be mixed for, and settling time. And that's another interesting topic in question because it also has to be representative of ocean environment. And especially as far as settling time, we see that many tests, they require quite a long settling time, allowing droplets to rise to the surface. But in a way, it doesn't represent the ocean environment where turbulence is always taking place. So after doing some experiments with settling time between 1 and 10 minutes, 1 minute was considered sufficient, that it is indicative of dispersion, and really waiting for much longer, just delaying test results and not adding much value. So these are ultimately test parameters that were selected. And then this equipment was shipped to Michelle Bufadel's group in New Jersey Institute of Technology, who did very fancy characterization. I'm going to read particle imaging velocimetry. I can never pronounce it. So they pretty much put particles in those flasks, and you can see small dimples here. That's why they're dimpled flasks, not baffled, because baffles are along the sides. So by rotating these flasks and observing them from two angles, they were able to build these velocity fields, measure the velocity, build these profiles, and they tested 150 RPMs, 200 RPMs, and 250 RPMs. And for all of them, they did 50 tests and got these velocity magnitude diagrams and dissipation rates. So eventually 200 RPM speed was selected. And by the way, that's the same speed that's used for baffled flask test as well, probably resulting in a little bit higher turbulence because of the baffles, but it is comparable in both cases to ocean turbulence and energy dissipated rate observed in ocean and in wave tanks. So we really wanted to make sure that these results are representatives and we can relate this turbulence to other tests currently available. Want to thank Paul Panetta and Nalco and a few other folks that gave us oils for tests. And you can see a variety of API gravity of oils that we tested, from 14 for Canadian sour to 48. And two dispersants were tested, Acel and Corexit, EC 9500. And if you're interested, there's a list of 30 individual tests that were performed. But something that may be interesting to note here is by intuitive thinking, one would say, well, Canadian sour seems to be pretty heavy, so it probably doesn't disperse that well. And I would expect, let's say, St. James oil to disperse much better. So keep that in mind, and I will show you a picture on that topic in a second. So 14 tests were conducted, 10 fresh oil, weathered, and some highly emulsified oil to see how this new test performs under these conditions. Typically, we would expect that on a vessel, you would only have two flasks set up next to each other, one with dispersant, one without dispersant. But because it was a science experiment and we were still refining the test protocol, you can see here on the back, you will have no dispersant test. On the left, there is a flask with Corexit. On the right, with Acel dispersant, just so we can see dispersant test a little bit closer to each other, because there is a clear difference with the no dispersant test. So this is what results may look like after 1 minute of settling. So clearly in this experiment, you see that fresh oil from the Gulf of Mexico, there is a dramatic difference between no dispersants added and dispersed oil. Based on this information and other information, environmental unit and scientific support coordinator may conclude that this oil is potentially dispersible. Same oil after significant emulsification. When you see this kind of results from the field, you may see, well, maybe this oil after this stage of weathering is not very dispersible. So you will be making that judgment in a unified command based on the visuals that you get from the vessel. And these are examples with different oils that were tested. Again, no dispersant flask is on the back, Corexit on the left, Acel is on the right. We don't see a tremendous difference, at least visually, between these two dispersants. Significant difference with no dispersants test. And interestingly enough, here's our Canadian sour. No dispersion without dispersant, and pretty good dispersion with both dispersants that have been tested. Interestingly, St. James oil, that's much lighter. really did not disperse as well. And maybe as Tim just mentioned, that was a droplet rise that played into this analysis. But definitely it's something useful to consider in addition to density and viscosity parameters you may already have. This is just additional visual that may help. And here's another example how not very effective dispersion may look like. That said, even if we see this not very effective dispersion, we have to keep in mind that this is a laboratory test under specific turbulence conditions. They may not be representative in the field. If waves in the field were higher, you may be able to see higher dispersion. And also we all have to recognize the confinement factor of the beaker itself. So there is an option in this field test kit to take the oil from that undispersed beaker and put it on a clean tray with clean water with no surfactant contamination and see if it actually sheens and spreads, and that way provide additional information for unified command as far as the dispersibility of this oil. So once this kit was designed and tested and verified, and did great job by hand cutting this foam slots in the Pelican case and positioning everything there very neatly with all the tools that are needed for performing tests, collecting the oil. Here you see 2 collapsible buckets to collect clean water, and here's this tray for additional tests for oil spreading if needed. Also includes 8 dimpled bottles to conduct several tests as needed. This case can be lifted and carried by one person. I have one in my garage. I cannot lift it with 2 hands, but it has wheels, so I can move it around as needed. So to make sure that this test is available for anybody who wants to use, this is a really kind of philanthropic effort for oil spill response community. Nothing is that proprietary. We are making all this information available, including entire list of purchases. So if anybody anywhere in the world wanted to make this kind of kit, here are all the instructions and where we got it and how much it is. You can build one kit just over $1,000, and you can create one of your own. So please, by any means, if anybody is interested, now it is available to you. And one thing that I am particularly grateful to Anna and Gina is for developing excellent instructions for this kit. So here you can see a 2-pager that describes how to prepare equipment, how to collect seawater, measure temperature and salinity, how to collect and dewater oil samples, how to put them in the beakers, how to test them, how to report results and to clean it up. So really clear, very excellent instructions. And they have been tested with responders. We are grateful to Clean Gulf Associates and MSRC staff. They went on a CGA boat in October of 2020, and I want to mention that it was middle of the COVID pandemic, but tests were conducted in the field in a very safe and collaborative manner. So really appreciate collaboration of response co-ops and Gina and Anne. So they took these instructions and the kit and they presented it to responders who have never seen it before. And just based on the instructions, responders were able to practice with them, collect water, collect oil samples, perform tests, and send to a simulated command post that we simulated as advisory committee on the other on shore. So, and we found that videos may be difficult to transfer because of the size, but pictures that can be taken by iPhone, by responders were pretty easy to transfer to the shore. And one absolutely excellent piece of deliverable is this dispersibility training video that's available on the YouTube. As soon as I go exit from this mode, I'm going to go to the chat box and we'll put the link, but you can also Google it. That video is absolutely excellent. It's very short and you can just watch it and you will see all the components. You will know exactly how to use it. It can be downloaded. So it's really for responders who want to use this kit. They can just watch it and use it very, very easily. So we built two kits. One of them is now sitting in Louisiana with CJ on the response vessel, and one of them is with MSRC in Texas. I have one in my garage. I offered it to OSRL to put it in Florida in case if we need any international response. But other than that, this is really our contribution to oil spill response community. Anybody who is interested can build this kit, use this kit. We feel that it's pretty simple to use. It doesn't solve all of our problems on dispersant decision making, but we feel that it will provide additional piece of information that a response community could potentially be interested in. So with that, I will be happy to take any questions.
Well, thank you, Victoria. I think this is a really exciting development, and I'm really heartened, I guess, by not only the thought and care that went into thinking about what components would be most helpful in this kit. I also appreciate, I guess, sort of the way you sort of sideboard, the concerns, what this kit is and what it isn't, how it can be used, how it could, results could be interpreted or how they should not be interpreted. And I really am heartened by the training, the videos, the outreach to particularly the oil spill response organizations. It just seems to me you're doing this entirely the right way. Not to make a buck, but to make progress. I'd really like to see what we have in Q&A for you and encourage the folks out there, particularly from OSRAs or other dispersant kind of folks, to weigh in, even if you're kind of shy. Help give us some reflections on Victoria's work here. Lindsay, do we have questions in Q&A for Victoria to start with?
Yes, we have a couple questions. How was the settling time of 1 minute selected?
They looked at, I believe, and Gina can correct me, and Antanas on the call too. I think they look at 1, 10, and 1, 2, and 10. And it appears that 1 was optimal because after 1 and 2 was not that big of a difference, and 10 was a big difference, but really 10 minutes of a settling time is extremely unrepresentative of ocean condition that never have this stop of turbulence allowing droplets to rise. So it was by trial and error and looking how different oils respond and what is kind of the soonest but most representative settling time that we can see results of.
Great, there's another question. How can this kit be integrated with the current RRT decision-making process?
That's a good question, and I guess it's up to every RRT, but really the idea is that in the RRT questionnaire, when it asks you, why do you think this oil is dispersible, we either put typically modeling results or I don't know, viscosity or density of initial oil. Now there is an opportunity to say that, and in addition to that, we believe oil is dispersible because we conducted these tests. And something, I guess we can think about several uses for this test. One is when you have a spill that you don't know what it is, and you don't know oil properties, and you cannot model it, so you can use this test for initial assessment. Also, you could use this test on subsequent days to confirm that oil is still dispersible and we still should continue dispersant separation and sometime extend that window of opportunity. I showed you that Canadian sour that somebody may have thought that it would not be dispersible, but in fact, you look at the test results and it's absolutely is. So you can do it in the kind of subsequent days as well. So it's just one more piece of information that now a responsible party can provide to regulators to consider as they are evaluating approval.
And one more question, can this be deployed in other countries?
Yes, so we advertised it globally. I'm planning on presenting it at Interspill. I shared it with OSRL. One consideration was that US is probably most litigative environment of them all. In UK, when we spoke with OSRL, they felt that there is no danger for them to conduct simple shake test kits. So this is why in OSRL and UK, they just use a bottle. It's not a very scientific way to do it, but they just kind of shake it and they show it or take pictures of that. And they were comfortable doing that. So in this situation, they really don't need this bit more sophisticated equipment. So I would say in the countries that responders are willing to do simple tests, they should do simple tests. In the countries where responders may be hesitant and may need a bit better protection from litigation, let's say, and where regulators demand greater consistency and accuracy of the results and something more documented, something that can be used for proof later on. And that may be, I don't know, US, maybe Canada or Brazil. Any country can use it now as they see fit. It was really our project to give people this option, so anybody anywhere in the world can use it if they want to.
Great. We have a couple of comments from Tom Coolaball. The oils that were used for the development of this field kit are now stored at the OMSET facility, perhaps for future comparison studies.
Yeah, thank you, Tom.
And Gina Coelho, peer-reviewed publication is pending.
Yes, thank you for reminding me, Gina. Yeah, Marine Pollution Bulletin publication is almost done, so it will be published in Marine Pollution Bulletin. I have presentation at RRT6. I'll try to get it into Interspill, so I will try to advertise this kit to folks, and also invite all of you to consider it to use this kit during exercises. We can play either actual responders on the vessel playing with the sample of oil on the deck if they have this kit, or we can play with decision making when we just take pictures that Gina and Anne already took and we send that, simulate sending it to a unified command to environmental unit and see how it can be incorporated in the decision-making process. So again, this kit is just fresh out of the project phase. It was just finished in December, just before Gina left for Bessie, which we are grateful to her to finishing this project. So now it's unveiling, and let's see where oil spill response community want to take it.
Thank you, Victoria. Awesome offering.